have a chat here. Go live. Let's see if you're live or not. Hello, hello, hello. Am I live? Hello. Hello. Hi, we have Bhaskar here. Hi, Bhaskar. Hi. Whosoever is here, just quickly write down that how many questions you guys were able to solve. समय हो गया है आपसे विदा लेने का. अरे कैसे भास्कर, कैसे, क्या हो गया? हाय मनुल. we'll start off in just 2-3 seconds, sorry, 2-3 minutes. Quickly just let me know that how many questions you guys did, how many questions you guys solved, all that stuff, everything that, so that we can actually get to know that how's the status going on for you guys. At least, like, for sure I would expect you to solve 4th question, 2 problems, 1 and 3. That's great. Susindran, 1 and 3, 2 was not able to solve. That's, yeah, 2 was a bit tricky in the sense that it was hard to figure out what to do and what not to do. So basically how usually we go off is, like, we'll go on, but usually we go off that we should add a stuff rather than removing, but here removing stuff was useful rather than adding. Cool. 2 problems, 1 and 3, no worries. Manul, 3 solved out of 4 questions. That's great. 1, 2 and 3. Yeah, that's obvious, because if you can solve 4, then for sure you can solve 3 also. Okay, something is making noise. I don't know what, but I'll do and mute this thing. Cool. Again, can we please smash that like baby for the folks who are here? We'll quickly start off with the problems itself. For sure, going on from the 1st, 2nd, 3rd and 4th. We are going on the chat, and then we'll start off with the problem itself. As usual, we'll go on into very deep of the problems, all 4 problems for sure. Can we please smash that like baby to 15 likes? That would be super great. It's usual, you are here, I am here at 11 p.m. daily, every alternate week for weekly contest, and every week for Leetcode Weekly Contest. Cool. Rohan 3 again, great Rohan. Aditya 2 solved. Bhaskar 1 and 3 same. Great Bhaskar, no worries. 1st and 2nd, okay. Aditya, hello, 3 questions solved. Haran 3 solved. Difficulty level of 4th. I'll say to think of 4th question, it's easy, but to code it up without having any errors, it's tricky, because there are multiple if conditions there. Thinking wise, okay, you can just directly think it is kind of same as that of longest increasing subsequence kind of problems, that okay, you just wanted something increasing here, just that the prefix sum needs to be increasing, that's it, and the prefix sum also in the groups itself. So that can be a bit easy to think of, okay, what can be applied. So to think of, okay, DP and binary search can be applied, it was actually easy part, but to code that up was a bit tricky. That's the reason, like, I'll go on in the entire dry run for you for the entire code. You will see that would be a big long video, as in the big long portion of the live stream. But yeah, Manuel, yes, 2nd was a bit tricky. Yeah, true. 2nd question was easy, but understanding the question statement is hard. By the example itself, it would have been clear, but yeah, placement nahi ho raha, ab kala jadoo ka hi sahara hai. That's true, but like, it's not that we need to entirely rely on placements. You can for sure parallelly keep on applying in the off-campus opportunities. I know it is not at all easy to apply off-campus and also to get the call back off-campus, but it's just that अगर हम 5 या फिर 50 जगह हाथ मारेंगे, 2 तो हाथ लगेंगी, तो हमें 50 जगह हाथ मारना है, उसमें से 5 वापस आएंगी, 5 में से हम 3 को कर पाएंगे क्लियर, लेट्स से ओए वगैरह, 1 का इंटरव्यू कर पाएंगे. तो ऐसे करके वी हैव टू ट्राई एज मैक्स एज वी कैन, राइट? कूल. व्हाट्स योर रैंक? इट वाज अराउंड 1.5 के समथिंग. First only, no worries Himanshu, I could solve 2 only, no worries Millie. We'll see. Cool, let's quickly start off with the video itself. We'll start off with the first problem. Just let me know if everything is visible, audible crisp and clear. So it just says that find the word containing the character. Now what we have to do is we are having the words and then we have a character. Now we have to say if this character is in this word, so put this in the index. If this character is in this word, put this as an index as an answer. The same, this A is, it is here, it is not here, it is here, it is not here. So answer is 0 and 2. 0, 1, 2, 3, 2 and 0 and 2. So just go and have a linear search. Just go and iterate on this entire words. Get the string out. Write another function which will compare a string S and see if that word C, that character C is actually inside this string S. If yes, then okay, it's great. If no, then simply don't push that index in your answer. That was pretty easy. Let's quickly see its code. So what we did was we just simply went on through the entire of our words, the entire words. So now we have got the string. This words of I is actually one string inside that word. Now I just wrote this is present function which will just tell me one thing, if the character X is actually present in my this string words of I or not. So I went on and have this string S and a character CH. Now I went on the entire string S and checked if that string X is present in my string S, then I am good. Simply return a true. Even after iterating on the entire string, if it is still not there, then simply return a false. Now at any point of time, if that is true, so it will go on inside my if condition and I can simply push back the index for the corresponding string in my answer, and that I can simply return my answer. Cool. We'll quickly go on to question number 2 and then we'll go on to the comments. But before that, can we please smash that like baby to 15 likes? Just 3 more, that would be super great. Just 3 more. Cool. Now it just says maximum area of a square hole in grid, and at any point of time, if you are not, like if the screen is not visible, if I'm typing or if the code screen is not visible, just let me know that. Cool. Now it just says that there's a grid of n plus 2. Again, this question is a bit tricky to understand, as someone said also, but yeah, like as Manul said, that it's a bit tricky to understand, but yeah, if you understand the example, it will be much more clear. The statement right here is a bit tricky, but example will actually make it much more clear. Now it just says, okay, I'll just show you by the example itself. Now example says I have n equal to m equal to 1. This n equal to represents I have 1 to 2 plus 2 lines, horizontal lines. Now whatsoever I have, this n equal to represents I have 1 to n plus 2 number of lines. You will see I have n plus 2 number of lines, right? So from 1 to n plus 2, which means I have 1, 2, 3, 4 as horizontal lines. Now the same will go for m. I will say I have 1 to m plus 2 number of vertical lines. I will have from, it will say I have 1 to 4, which is 1, 2, 3, 4. It will say I have 1 to 3, which is 1 to 3. So sorry, 1, 2, 3. Yeah, I have 1, 2, 3 vertical lines. Now this h bars represents that I can remove these. I can remove these lines. I can remove these lines. I can remove these lines, right? Now this V bar represent I can remove these vertical lines. Okay, I can remove this vertical lines. Now it just says after removing all these lines, what's the maximum square size you can actually build up? Now for that you can simply see that in this example I can remove all the lines, so everything will be removed. It's just the entire rectangle will remain. This entire rectangle will remain. This one. Now if you know that the length is 1, 2, 3, the length is the actual rows are actually 3, the columns are 2, maximum square size can be a 2 cross 2 itself. So I know that answer should have been a 4. That is the answer 4 itself. Now that is the crux of the problem statement itself, and it's the entire thing. Now what the entire thing in this is that you just simply did one thing. First thing is you went on and removed all the bars whatsoever were possible. You removed all the bars. In this it showed that okay, you make the third bar stay, but that is not useful for us. For me, I can remove all the bars, like whatsoever bars are possible to remove, I remove all of them, and then I can just figure out what's the maximum area of what's the maximum row length or height length. And then if I know the row length, I know the height length, I know for sure that okay, the maximum area will be whatsoever height, because I want the square, I don't want a rectangle. So if the height is 3, like width is 2, so I know I'll take the minimum of both of them. Minimum is 2, so a square can be formed of size 2 itself. So one thing we have got to know so far is we will remove everything whatsoever we can. Now let's imagine something here. Aryan, okay, so now the part which comes in our mind is that how we will actually figure out what is the length we should take, because it can happen that I will have something like this. Okay, this is one thing, this is one thing, this is one square, and this is another square. So it can be something like this. So which means these dotted lines I have removed. Let's say these were the lines which were dotted and I have removed these lines. Let's imagine that part, right? Let's imagine these were the lines which were dotted and I have removed. So for sure, I have just known one thing, that I can remove all these lines. So I just removed them. Now this is the part which remains. Now if this part is remaining, what can you see? What can be the height and width of all possible combinations? It can be this height, this width, right? For this, it can be this height, this width, right? It can be this height, this width, right? It can be this height, this width for this rectangle. And again, I am taking a rectangle, but ultimately make sure if you have a height, you have a width, just have a minimum and just do a multiplication of both of them, because you want a square rather than a rectangle itself. Now this height, this width will give me this rectangle, this height, this width will give me this rectangle. So it is kind of obvious if I can just figure out what is these ranges, which means I know I am starting from 1. If I can just know, okay, I can delete them and then I can figure out the next point, let's say 3, and then maybe I can delete the next ones. I can figure out the next point, which is actually 5. So maybe with this I can just find out, okay, this is of length, let's say 3, this is of length, let's say 2, this is, and so on and so forth. Like although it's 2, but yeah, just have a crux that okay, if we can just figure out these points itself, where these lines are. So again, right now we are thinking, can we figure out these lines? I'm not saying, I'm saying figure out the remaining lines. But shall we do that? Let's look at the constraints. Constraint says that we can have 1e9, which means 1e9 lines I can have. If I can have 1e9 lines and I can remove only 100 lines, bro, hold on. If you are saying 1e9 lines, you can remove only 100 lines. Are you kidding me? You can still have 1e9 lines. So your list, your entire list will have 1e9 lines. That's pathetic. Rather, let's go on the opposite way. Aryan, what I can do is that if I have a line, let's say 1, 2, I have a 3, I have a 4, I have a 5, I have a 6. Now I say you, okay, if I remove a line 2, so you will say if I remove a line 2, I will actually form, I removed one line, right? I removed just one line. So you saw, by removing one line, I was able to make a height of 2. Great. What if I had removed another line also? Now I would have made a height of 3 from this 1, 2 and 3. 4 minus 1. Okay, so by removing the lines, I'm actually trying to make a height of mine. But wait a second. What if I have removed some other line, which means I removed a 2, okay, I got a length of 2, which means if I removed one line 2, so I get a length of 2. If I removed a length 5, I'll still get a length of 2. So how it changed? When I removed a line 3, I got a height increased by 2. Sorry, increased by 1, which means this became a 3 height, new height. Now, if I am removing another line 5, I'm just getting one height, which is actually this 2 itself. So you can actually see that your answer is nothing but if you are removing these consecutive lines. If I remove 2 consecutive lines, I will have a height formed of 3 blocks. If I removed these 2 consecutive lines, I got a height form of these 3 blocks. When I removed just one line, I got the height of 2 blocks. So now our solution just goes inside the fact that I have these number of horizontal bars. I have these all horizontal bars with me, right? These all bars. I can just go and figure out, okay, I have a 2, I have a 3, I have a 5 in my H bars array. So I can just go and figure out, okay, just go and find out the number of consecutive elements and just have the count of it. What's here the count? You will see the count of consecutive elements are actually 2, because in H bars you will have a 2, 3 and 5. I have modified the input, but yeah, H bars will have a 2, 3 and 5. So with this 2, 3 and 5, you will see that this 2 and 3 are consecutive. So my consecutive length is actually right now here as 2. This consecutive length of 2 will give me a height of 3 blocks. Consecutive length of 2, which means removing 2 consecutive lines, will give me height of 3 blocks. So with this, I know the height it can give me, removing these 2 lines can give me, is actually 3. Now removing one line, which means, okay, I just have one consecutive line removed. So one line removed, it will give me a height of 2, which means just number of consecutive lines removed plus 1. With this, I know that it can give me a height of 3. It can give me a height of 1. So now I know that I can just grab the maximum height from here itself, right? And the maximum width, and the same I can do for the width part. If I removed some of the vertical lines, then for sure those would contribute in a width. So I'll just try to remove the consecutive. I'll just have a consecutive count of width lines, vertical lines. With that, I will know. I'll just do a +1 to have the count of vertical cells I'm removing. So with that, I'll know that what's the count of vertical cells I'll remove. I'll take the maximum of the horizontal cells, maximum of the vertical cells. Just simply, firstly, that can actually be a 4 also, the maximum one, but you want a square, so you will take minimum of 3 or 4, which is actually 3, and then multiply it by 3 itself, because you want it a square area. That will be actually a 9. So you will see the same thing. If I just do, you have a bar 2 and 3, that's a consecutive bars. So these consecutive bars being removed, they actually give me a height of 3, and that is the same thing. Now this 2, 3 and 4, 2, 3 and 4, again this would give me a height of 4, 5. You see, because I have removed 3 consecutive bars, vertical bars. Now take the minimum, because you want a square, take the minimum, it's actually 3, multiply by 3, you will get 9. That's how you can simply get this solved. So rather than taking taking the lines which are actually there, take the ones which are being removed. Now being removed will actually give me number of blocks I can have because of these removed lines in the horizontal and the vertical part, and with that take the maximum and multiply that and get the answer. Cool. Let's quickly see that how we can code this. Again, the only crux was just to figure out that you have to remove the lines, and the removal of lines, because of the constraints, removal of lines is the one you have to choose. It's entirely on that. Again, it could have been the case that the constraints of n would have been small, then maybe you could have used a line sweep kind of algorithm or something like, okay, take the actual ranges and multiply and keep on multiplying. We have already seen some kind of problems like that, but in this case it is a bit different. Why? Because you actually have to remove lines, and by removing lines you have to tell, okay, you have to tell what's the contribution after removing those lines, and as in how many number of height you can actually get. Cool. Let's quickly see the code. Again, it's pretty easy. We'll firstly have to sort the bars. As you see that we want consecutive length, like maximum consecutive horizontal length and maximum consecutive vertical length. So I just firstly sort these bars, then I have to find the maximum horizontal length and maximum vertical length. Again, for maximum horizontal length, I'll just go and try to see what's the maximum consecutive count. So I just went on from the entire array of horizontal bars. I just have this count initially, because for sure if you are at one element, the count is for sure 1. Now you just have to expand that and see that how long you can increase the count. So I just try to expand it, which means I just say firstly if the next index is even possible to have inside my array. If yes, then just check if that next index value is actually +1 of me. So me, I am h bars of I, I'll do a +1 and it should be my next value. So if it is actually there, which means I have found the next consecutive element, which means if I am 2, I have found a 3. If I am 3, I have found a 4. If yes, that's the case, then simply increase the I. It's actually good to increase, and then also increase the count because you have found a length 2 itself, which means you have increased the length. Increase the length as in the count. And at every point of time, keep on updating your maximum H. Maximum H says maximum consecutive horizontal count. You will do the same stuff for your vertical, maximum vertical, exact same stuff. You will just go in the entire array, count I+1, I++, and have the maximum vertical count. When you have got the maximum horizontal count, maximum vertical count, again, get the, because you wanted a square, get the minimum of maximum vertical +1. Why +1? Because if I have lines removed as 2 lines removed will give me 3 blocks. So 3 blocks, which means +1. Always +1, always +1. Now I have 3 blocks of vertical and 4 of, let's say, horizontal, but I wanted a square, so I'll take the minimum. So I have got the 3 blocks, which is the value as the 3 blocks, and just simply do a square to get the square area of that answer. Cool. We'll quickly read the chat now, and then we will go on to question number 3. Before that, can we please smash that like baby to 30 likes? That would be super great. Just 2 more, right? What college did you choose? Mine was NIT Allahabad, CSE. What is your rank in today's contest? It was around 1.5 or 1.6. Because I did a blunder in question number 3. I tried doing recursive, like memorization, but then I realized I'm much more comfortable in bottom up, so I then wrote a bottom up DP. Cool. I am only able to do 1 questions. How to improve? I have done DP also, but not able to solve 3. 1 also, please help. Bhai. See, for 3rd question, I'll say that it was not a very, by on surface, it looks a very standard normal DP, but it was a bit tricky DP. I have seen many people did some wrong submissions here, as you can see. It was not exact, and it looks like on surface a very standard DP because constraint also says the same part, but it was a bit tricky. But still, if you have done RDP or if you have watched the DP intuition building playlist, then you should have at least reached to a point like for you Pratyush, were you actually able to think of the logic or intuition behind that, or was it also not possible for you? If yes, if the intuition was possible for you, if let's say if the intuition was possible but not the code was possible, okay, that's still a hands up, like that's still a thumbs up. If the code was not possible, as in like you coded up but you then got a error in some test case, then still it's a thumbs up. If from very scratch you would not able to think of the logic itself, then we have to work on more DP problems, because it is a kind of a standard problem which replicates the standard concepts, but it was a bit tricky to implement. But yeah, that was actually good. Swapnil, Ram Sarji, Ram Swapnil. Millie, I did it using word of I.find x is not, that's, see, what Millie did is actually what interviewers are looking for. If you are using any, again, I did not use this, that's a fault of me because I coded mine up. It's a contest, although it's a contest, it doesn't matter how you code this up, but if you are using any language, you should be knowing its STL very properly, as Millie used string NPOS, and also like finding in that string, that is using the properties of STL and solving it in one line. That is very important for interviews. If you don't use this, like let's say if I just write the if I just write the function again just to search something inside a string and some STL is present, the interviewer will flag this as a red flag. So if you don't want to be a red flag in an interview, please make sure you remember everything of your language specifically if you are using it. So for sure, I also would have been flagged as a red flag because I did not use the inbuilt STL properties to solve question number 1. But yeah, I'll remember that fact, and you also should. Cool. We can use a find method too. That's great. RMI, I use the ChatGPT to understand the problem statement of second question. Is it fair? I'll say it is not fair because during contest, like you can, although you can use any of the online resources for sure, it's always fair. But I'll say that you should try to understand with the example. Like I'll first ask you, did you read the example itself? Because at the first point, I could also not understand what the problem was saying of question number 2, but then I used the example itself to understand what it was trying to say or what we wanted to have. So I'll say that please use example first. I exactly imagine this figure in my mind. Thanks, Miliaroda. Aurora. Bhai, I'm only on one question. That's done. Pratyush, how to improve? Improving is just practicing and also practicing faithfully to you. I've seen many people just like they might just watch the video or they might even not watch the videos. I have seen even if you solve it, firstly try it by yourself. If yes, then solve it. When I say solve it, as in like try it by yourself, watch the video. If you have watched the video, watch the part of intuition building, code it by yourself. If you have watched the part of intuition building, you tried to code but you got the wrong answer, then look at the code itself. That is how you should actually process the videos. Pause the video, go back, code it up, come back to a video and see if you are actually following up with the follow-ups of the video itself. And again, CP entirely practice in a right direction. Right? Let's move to third super fast. Yeah, that's let's go. Can we solve it using greedy app? Which one, Murari? Do we have solution for tomorrow's contest? Yeah, for sure. Every week we comes in, you can just go and check the live streams. How should I improve in contest? Please, need help. Thankful for this live stream. Bye. Thank you so much, Pratyush. See, to improve the contest itself, try to give virtual contests. As I have already spoken, for the last 8 months, we have all the live streams on our channel. For October itself, when I was not regular on YouTube, I have still done an entire one-day live stream for all the contests of October itself. So you can just go and have a look. Again, just go and if you're starting off, just go and do live contest, virtual contest of the last 8 months, and that would be more than sufficient. Cool. We'll go on to next comments later on, but let's quickly go on to question number 3. Then we'll go on to question number 4. But yeah, before that, can we please smash that like baby to 4x? Just 3 more. That would be super great. Minimum number of coins for fruits. Now it just says that you are at a fruit market with different type of exotic fruits on display. Now I am having a one indexed array as prices, where prices of I denotes the number of coins needed to purchase the ith fruit. Okay, if I want to buy the ith fruit, I want the prices of I as a price to buy the fruit. Now the fruit market has the following offer. The offer is that if I buy the ith fruit with this cost, because I want to purchase with this cost, I can get the next I fruits for free. Again, please make sure that the array is 1 indexed. In this question, my array is 0 indexed. So if I buy this 0th index fruit, still I can purchase 1 fruit, because by question it is actually 1 indexed. If I buy the index 1 fruit, I can purchase next 1 fruit as free. If I buy this fruit, I can purchase these fruits as free. So these 2 fruits as free. We'll take the next bigger example to understand this, but yeah, you should make sure that this will impact your indexing. So please make sure to resolve your indexing accordingly, because array is 0 indexed while the question is asking you to process everything in 1 indexed. Because if I purchase the ith fruit, I will be free to buy the next I fruits without any cost. But there's a caveat in this, that even if I am able to freely buy it, still I might choose to pay for that fruit. Why? Because of the next j fruits that I can get as free. Which means that in this example itself, you can see very clearly that I am at this shop. Firstly, I will for sure have to buy this fruit. There's no option that I cannot buy it, or like I should not buy it. I will have to buy it. Now, as it is ideally at the index 1, 2 and 3, I just mark the indexing 1, 2 and 3. So for sure it is at the index 1. I'll buy it. I can just have 1 fruit as free. I can have this as free. So ideally, you should be saying, okay, Aryan, if this is free, so why will I spend money on it? I'll directly go on to the next fruit and I'll just buy this one. I'll say, if you had gone directly to the next fruit and buy that one, so your cost would have been a 3 plus 2, which is 5. but you will see the answer is 4 because you wanted to spend the minimum number of coins. Oh fuck. Okay, I just had it not visible. Cool. Sorry. So again, coming on back, a quick, that's the reason, like I just missed it first. So the problem statement you have already read. It just says that we are having a one index integer array prices, where this prices, thank you so much for telling. Pen not visible, now I guess it is visible. Cool. So it just says that we have a one index integer array called as prices. The prices of 5 just note the number of coins I have. Now if you purchase the ith fruit, it just says that I can just get the next I fruits for free. Now this index is 0. This index is actually 1 based. So what could happen is that if I buy this index, if I buy this index 1, then for sure next one will be free. So you might imagine and start saying that, okay, Aryan, what I will do is I can buy it. I will, if I am the first shop, I will have to buy it because it's not free. I have to spend cost on it. So I'll buy it. Okay, I have taken cost of 1. With this 1 at index 1, I have spent the money. With this 1 at index 1, I know that, okay, for the next 1 elements, for the next 1 fruits, it's free for me. That's great. It's free for me. So shall I buy it? Shall I not? Although problem says that even if you can take the fruit J for free, you can still purchase or you can still spend money on it to receive the new offer. So ideally, if you just think, okay, let's say if I don't purchase it, I will go on to the next fruit, which is actually at index 3, and I'll just purchase it with the cost of 2. My cost will be 5. With this cost, you will see that, okay, the cost is minimum is 4. I wanted the minimum cost, minimum number of coins I want to spend. So what if I would have although it was an option for me to just not spend money on this fruit, but still I choose to spend money on this fruit. With this, I will get the next 2 fruits for free, which means I'll spend 3. Okay, I'll spend 1 also. So with this, I'll get the next 2 fruits for free. That's the reason I don't have to spend the money on my 3rd fruit, and that's how I can get the fruit for just 4 cost. Now, whenever such a problem comes in, very normally we just start thinking of take and not take. It's just that, okay, I have a fruit with me. I can just choose to spend money on it, and I can choose to spend no money on it. So I have a fruit with me. I just choose to spend money on it. Aryan, there's no choose. You will have to spend money on it. Why? Because it's not free. You can only choose to do something when it's actually free, but it's not free. You will have to spend money on it. So let's say I do a purchase on this. If I do a purchase on this, again, indexing is actually, for you the array is 1 base, for you the array is 0 based, but right now let's mark the indexing as 1 2 3. But remember to actually use or modify that in the code itself. Cool. What we will do, we know exactly one thing, that I am at this, I will just do a purchase option. So with this purchase option, I have to make sure and mark the next I elements as, I can just put them or take them as free. I have to just mark them. And can I, Aryan, so you are saying for every index, I have to go on to next I indexes. Are you saying that part? Yeah, I am saying that part, and that's also is possible because my constraints are just up to 1000. So for sure that is possible. Cool. Now with this, what you might see, okay, Aryan, with this fact, if I purchase it, I might choose and I might say that, okay, for the next I, it is actually free. But when it is free, when that entire thing is free, and for sure if I just say that it is a free, still I might say that, okay, even if it is a free, still I can just try paying for it. As you saw for index 2, you try to pay for it so that you can avail the next offer. So you might still try to pay for it. If you pay for the index I, then you can still try to pay for the next I, or you can still try to avail them for the free. But what if it is a free? If it's free, the current element, if it's free, then you might actually end up in a confusion that what to do for the next value. Shall I do and get that thing as paid, or shall I do something else for it? So if you will go on and see that I actually tried the same stuff, the same recursive stuff which I'm telling you. But then what happened was, and I tried it and I got the wrong answer. And I'll tell you I got the wrong answer at what point. I got the wrong answer at this test case. This one. Okay, this one, it's 14, 37, 37, 38, 24, 15 and 12. Indexing, again I can mark it as 0, IDs as 0, 1, 2, 3, 4 and 5. Oh, it's 0, 1, 2, 37, 37, 2, 3, 38, 24, 15 and 12, 5 and 6. Yeah. So this is what I did. This is what I got. So basically I just tried, what if I just purchase the current ith index value, and just maybe I just try and say that the next element is either free, or if it is not, I can still just try to pay for it. It means it is not free. If it's free, then simply take that as free and try to say the next one is actually paid. So just saying this part that the next one is actually paid is not something which is completely correct. Then what I did was I wanted to debug this entire thing. Then I realized to actually debug, everything is processed bottom up, right? Even if recursion goes down, it will still try to process the last part and then we come back. I was starting from here itself. So I thought, let's do the same thing. Let's try to replicate the same thing which the recursion could do. And again, it can be solved with recursion, but to explain what is happening or what we want to happen, let's go and see how this bottom up can or will work. I am at this 6. I know if I take this, again, it's actually a 0 indexed. So if I take this indexed 6, I can take next 7 elements, which is the next I plus 1 elements I can take for sure as free. I can take next I plus 1 elements for sure as free. So again, but you will say, Aryan, you are saying that you are paying for it. If I pay for it, then I just need to give a cost of 12. Let's say that the array is from here itself and up till the end. For sure, you have to pay for it. You will pay amount of 12. And you don't have to worry for the next part because there is nothing next for him. Cool. Now, again, now let's see if I have an array up till here at this point. If I have the array here, now if I purchase this person or this value 5, I know that I can purchase the next. I plus 1. Why I plus 1? Because index is 5. So for sure, these are the index is 5. I'll just write the one indexing here itself. The one indexing I'll just write in a white color. One indexing is actually 1, 2, 3, 4, 5 and 6, right? And yeah, here's 7. So I know for sure that I can purchase the next 6 elements for free. So I can just do one thing, bro. I am here. I will have to purchase it, and the next 6 elements are free, and there is nothing after it. So for sure, I'll purchase this with a cost of 15. The same you will see I purchase this with a cost of 24, because for sure the next 5 elements are free. As simple as that. I'll purchase with the cost of 38 because the next 4 elements are free. I'll purchase with the cost of 37. Why? Because the next 3 elements are free. Oh no, Aryan, no. If you purchase this with a cost of 37, the next 4 elements are free. Okay, that is good, but you still have to pay for this one. So shall I blindly go and add this number 37 in my value? Because I know that, okay, I will purchase this I will have to purchase this with the cost of 37. So my cost of 37 will always be in my purchase value, but then I have to buy all of them in the right. I can get the next 3 for free, but still I will have to go and purchase someone else also. Now that is the part. So in this you will see you can just blindly go and purchase this next element because these are free, and if you purchase this, it will make sure that this number 12 will make sure that anything after this, if you're purchasing, will give you the minimum cost, because I'm just trying to find the minimum purchase value itself. So it will give me that anything after the, if I will purchase, it will give me a minimum cost of 12. So I can just simply add a 12 here. But hold on. Why did not try this value, or this value? Because this also makes sure that anything after that I can purchase it. Anything after that I can purchase. Anything after that I can purchase. So ultimately what I did was, I did try this value, but I also will be trying these values also. You remember, these are I plus 1 values. If this is index I, these are I plus 1 values. And for sure, I will always try a one more value, which is after this I plus 1 values. So instead of saying I'll try 12, I am saying I'll try these I plus 2 values after, because I plus 1 here, n plus 1, like 1 here. I'll try these I plus 2 values afterwards and see what is the minimum I can get. And that is because, see, even if, let's say, if this would have been a 4, let's imaginarily say if this would have been a value of 4, then it would have showed me that if I would have taken this value, I can actually get the purchase, like I can get all the elements from here up till the end with the purchase of just 4. So that is one thing which I can get. So I'll just take the minimum, which is this I plus 2 value. So I'll just get the current value as 37 plus 12. Right? So you saw that I am just trying for next I plus 2 values and taking the minimum out of all of them. And why these I plus 2 values are more than sufficient? Because it will make sure I can reach up till the very end of the entire array. Because at this point itself, I make sure it's a minimum value and will try, and this will make me reach the entire left part. I will make sure when I'm working from the very end. Okay, cool. Let's go on forward. This says my index is this will say me that I can try for the next 2 elements, right? And for sure I told you that I will try for this other element also after this. So I know that ultimately I can try for these all values, which is minimum. So I'll say that minimum value is 24 here. As you can see, it is big. So this I will have a purchase cost of 37 plus 24. Right? Okay, cool. Now with this value, I know if I purchase this, I will have a cost of 14 for sure. Now I will just have to try for the next one value, but I also can try this value. So I can try these 2 values. What is minimum? This or this? For sure, this is minimum. So I'll just simply add this 37 plus 12. So this is the minimum cost what I will incur ultimately to buy all my fruits. So that's how you can simply solve it. Again, just simply at any index point, you just go and check the minimum of next I plus 2. Firstly, you will just for sure be building your entire array from the very end itself. And while building the array from the end itself, you will just simply say that I'll take the minimum of the next I plus 2 elements from my DP itself, and that is more than sufficient for me. Cool. Let's quickly see how the code works. Again, it's exactly same as what I showed you. Firstly, I just have my n as the size. I have my DP initially with the maximum value because I want the minimum value in my answer. I went on from the very end itself, right? I checked for the current price, which is price of I, although I did not use current here itself in the entire array, so that is not required at all. Then I checked the count. Now his count is I plus 2, as you can see, it is I plus 2. That how much count of elements I actually wanted to check after this I element. So firstly, I'll just have a quick check that like as I showed you for this value, let's say, I'll first have a quick check that do I actually need to go and check something, or is it okay that if it is actually exceeding my limit, let's say for this value, I should add something here, or is it okay because it has reached the end? As you can see for this, if I take this, so I know the next 4 elements are free for me. Why? Because I know that it will simply reach the end. So I can simply take the count as 38 itself. So the same thing I'll do. I'll just check if the I plus count is more than equal to n, which means it has reached the end. So for sure, I can take my DP as this value itself, which is price of I. So this price of I is more than sufficient to cover the entire array up till the end. So that is what I am taking right now. Okay, when this part is done, which means I have just assumed the ending portion that okay, it can for sure reach the entire array end. Now I will go on to the next count elements. As you will see that I just start from the index I go on to next count elements, count number of elements, and for sure you wanted the minimum of n+1 because ms1 because you don't want to exceed the array size. So I just go on to the next count elements starting from the index i+1, next index from I, and get the minimum of whatsoever dp of j values it had to offer me. Simply, I just it's another way to say the same thing. No, it's in that part. Now I just have this value. Okay, price. I just added the price of I in the next dp. So basically, I'm just taking the minimum of the dp of j values for the next count elements. When I've got this, I'll update my dp of I with the minimum value whatsoever is possible, and ultimately returning the dp of 0 because that is storing the answer to start from 0 and go up to the very end of the array. And that's how you can simply get this solved in O of n square, because the constraints actually says that you can actually solve it in O of n square. So yeah, that's how that can be solved. Cool. We'll quickly go on to question number 4. That's the trickiest question. You can see with the count also. See, thinking again was easy for this question, but the implementation part was a bit tricky. That's the reason. How I will explain this question will be a bit different. Again, I'll tell you the intuition, I'll tell you the logic, but I'll not tell you the logic from very scratch. As in, how I usually tell or how I usually teach you is, I tell you the intuition, which I'm going to tell. I'll tell you the logic with the intuition, and from the logic itself, I dry run you. From logic, I dry run you, and then ultimately we go on the code. But now how we'll do is, we'll tell the intuition, like we'll see the intuition. From intuition, we'll see the logic. Now, we'll not dry run with the logic. We'll dry run with the code. We'll see the code. We'll not actually like go through the code, but we'll have a code on the side. We know the logic. We will dry run from the code itself that how that is being done. Because see, logic is easy for the solution, but the code implementation is a bit tricky. So we'll go in this route. Cool. We'll go on to the chat quickly, but before that, can we please smash that like baby to 50 likes? Just one more, that will be super great. And we go to the chat. We have Infinity Gaming back. Hi Infinity Gaming. Quite easy, sir. Great. Murari, can we solve the third problem using greedy? Third problem using greedy. Third problem using greedy. Where's the third problem? Third problem using greedy. Nope. I don't think so. Sir, I'm able to do 2 or 3 questions. Will I be able to crack good companies? See, I'll say that when you say good companies, the companies, if you consider good companies like Amazon, Microsoft, you will for sure be able to crack it. I'll not say that for sure, like 2 or 3 questions, as in you can, like, it might, like, again, let's say it. You have Microsoft, Amazon, like I'm taking just the big names for you to actually just get comfortable that, okay, even big companies don't ask tough questions. Google, Adobe, Amazon, Microsoft, Flipkart, Adobe, all these ones, if you are solving 2 or 3 questions, which means medium questions, that's more than sufficient. Even in OAs, you can clear it, because usually it's medium, a bit extended to medium hard in the rarest cases, but yeah, you will actually be able to crack it. But for the companies, let's say like the shop or sometimes Goldman, sometimes, because it depends upon the hiring phase. If they want to hire rigorously, they will lower the bar. If not, they will upper the bar. That's how the companies work. So Google, Facebook. So with this, what will happen is they will try to ask the Leetcode hard question also. Maybe in OA, but also in their interviews itself. So I'll recommend that if you are able to solve 1, 2, and 3, again, with the speed, if you're able to solve 1, 2, and 3 in just 30 minutes, great. You can for sure crack any good companies. But just to be on the safe side, please always keep on trying to solve question number 4, because that will just always keep you on the safe side. That, okay, no matter if the conditions get worse, which means companies stopped hiring very aggressively, still we would still have a chance, because as soon as the companies like relaxes, they lower the bar as in more people will come in, more people, like less competition. But as soon as the hiring freezes comes in, you will see the bar goes up. increases, like hiring goes down, so competition grows up. So that is how we have to make sure. But yeah, problem solving 3 questions fast is a safe side. Cool. No, my intuition was like take and not take. Yeah, that is like pay or have it free. That's the reason, like I take, if I just show you in the beginning itself, I just take it. You can have it a free or you can just actually pay for it. Even if it is free, still you will pay for it. If it is free, then it's actually free. So yeah, that is how this entire thing would actually work. Himanshu, I got pick and not pick intuition but couldn't implement it. Yeah, that's the things, like that's the main thing. It's actually pick and not pick, take not take, pay not pay, pay free. So that's the entire thing for it. It's just that the implementation got a bit tricky depending upon if it's free or not. Cool. Robber with no consecutive houses. Kind of. Billy Rhoda, same. I did. It is similar to robber with no consecutive houses. But yeah, I was able to see robber with no consecutive houses are actually binary search problem also, DB problem also. So that's a mix for it. I was able to solve 1 and 3 during contest, but during contest I was not able to solve. But meanwhile, if the folks are watching in, can we please smash that like baby to 55 likes? Just 2 more would be super great. But yeah, I was able to solve 1 and 3 during the contest, but during the contest I was not able to solve 2, 1. But after contest I was able to do so. No worries, Supreet. Question 2 was a bit tricky, not a clear explanation of question 2 problem itself. So yeah, that we can take it lightly. Right? It is similar to robber houses. Yeah, that's like, I remember this question, but don't remember the exact question, so not sure of it. Understanding the description is a huge part of the problem itself. Yeah, that's true. Bro, segment trees for playlist banao, please. Segment trees. Okay, Krishna. Rahul Yella, yes, bro. Segment trees playlist needed. Yeah, cool. Segment trees playlist is demanded. Okay. 4th question was ultimately tough. Yeah, that's true. Jaldi karo, kal contest bhi dena hai. That's true, Ritik. I see, chaos is just giving contest. For me, it is, I have to make the tomorrow's problem video also. I have to make the video for the Instagram. Like if you don't know, then this is the new channel for us. And we just post in the programming logics or memes in a funny way, just for you to understand. For example, in this video you can just go like this one, if you can just go and check, this is actually just representing what ways we have to follow for the steps to code. Or in this one, if you just go and look, it's actually swapping up the variables using third variable, giving example of condom and so yeah, that's how in a funny way we try to go it. So again, for you is just giving contest. For me, it's making a video for the Instagram channel for the tomorrow's the problem which comes daily, and then the contest itself. That's gonna be a big one. But yeah, cool. Not visible. Screen is visible. Hi Ashutosh, 1 DDP not visible. Yeah, that's true. Pen not visible. Can it be solved using knapsack? Knapsack is also take not take, right? So anything you can say for just any words whatsoever for it, that will actually work. It is similar to frog jump of k steps, similar to that. Yeah, that's true. Intuition is same. Yeah, can be solved using knapsack. Yeah, you can say it. Can you tell me, Pratish, you can use pick not pick? See, pick not pick, take not take, knapsacks, everything are same. Please, everything are same. For question was ultimately tough, that's true. Haran, please, can you give me the code? Haran, solve 3 problems in 30 minutes. I am in Tripadi, Bangalore. That's great, Prajit. That's great. Thank you, sir. Sir, I am BTech first year. I solved 114 questions on Leetcode. See, number of questions, Sai Harsha, number of questions might not matter. Considering you have tracked the timing of as soon as you read the problem, and how much time you were able to solve it by yourself, as in the thinking part, and how much time you were able to code it up. Because thinking part is one part. After thinking, coding that in the 5 to 8 minute range is another part. So I'll say that even if you are actually solving the problems daily or something like that, then please focus on that how fast you can code. because it's very important in the interviews, especially for the companies who have a restriction on the time. For example, Goldberg has 1 hour foundation, D Show has 1 hour like that interview timing, Google has 45 minutes. So you should be able to come up to a solution, code that up, and also code the follow-ups. So you should be able to code it in less time, which is actually 7 to 10 minutes. Although people say 5 minutes, but that's a very imaginary number. You cannot code something medium or medium hard question in 5 minutes. That's not at all logical. But yeah, just improve the coding speed also. Cool. Thank you, sir. Sir, I am reading first. Cool. We'll go on to question number 4, and then we actually go on to the other comments. Cool. Again, if you don't know question number 4, how we will go on to, we'll first see the intuition. Then we'll see what's the possible logic you can apply. Then we will try run the entire code on the logic. Then we'll come back to the logic, right? Because else you won't be able to understand it, because you can see for sure it's in front of you. Many people tried, which means logic was clear to everyone that what's going to happen or what can happen. But you will see number of wrong submissions. Why? Because of the if conditions added or because the cases being added here. That's the reason I will dry run this first. With the logic, I can just dry run for you guys, but yeah, you won't be able to understand it. So I'll take the question, get the intuition to you. From intuition, we'll get the logic, possible logic. When we have the logic, we'll not dry run with the logic. We'll dry run and see, okay, we have the code with us. And the code I have like taken from this guy. This guy, like stupid RR, like I don't think this one is actually a good, like you can say it's a good, but it's not understandable, like it's not that intuitive, you can say. But yeah, you can still go on to it, that's up to you. But yeah, we'll go on to the entire code. It's just the logic is same, crux is same, everything is same for all the versions. Cool. Let's see what the problem says. Meanwhile, if the folks are watching in, can we please smash that like baby to 60 likes? Just 4 more will be super great. Find maximum non-decreasing array length. Now you are giving a 0 index integer array called as nums. Okay, we have an array of nums. Now we can perform any number of operations where each operation involves selecting a sub array of the array and replacing it with some of its elements. For example, I can choose this array, I can choose these 2 elements, and I can replace that with a number 8. So you want a kind of, and see, when I say increasing, you actually mean non-decreasing itself. So you want a kind of increasing sub array. Now increasing basically array. Or you can say, Aryan, what I want is, I want the maximum length of this sub or of this array, ultimately entire array. Can you relate this with the longest increasing subsequence? With, let's say you have an array, you want the subsequence being longest increasing. So you will see that, okay, you wanted a subsequence which is actually longest in length, and that's increasing. Now, how it is related to that? Simply, as if you just go back and see, then you can say, okay, it is one sub array, it is another, it is another. So instead of this element right here, I can keep track of the prefix, like I can keep track of the prefix sum, or basically the sub array sum. Now when I say prefix sum, the prefix sum is from here to here. I can keep track of the sub array sum at this point of time, at this place, and I can just say, okay, this is increasing, this is increasing. So ultimately I could get a increasing, longest increasing subsequence kind of format, or basically indicating I can have a maximum length of non-decreasing array that can be made after these operations. So okay, we've got the intuition that it looks something like that. Now the part comes in that the constraints are pretty tight, 1e5 as normal for the hard question. How will we solve it? First thing which comes in our mind is we want the longest increasing sub, like whatever, sequence, array, something like that. We want something longest increasing. For that, we saw that we want firstly the sub array sum at every point. Now to find the sub array sum, to find the sub array sum for the array which is not changing, which is not dynamic, we use the prefix sums as array. So what I can do is, to get the sub array sum of any block, I'll use the prefix sum pre-computation. That is very normal. That's the first point, first intuition, that okay, what can we use in our logic? We can use the prefix sum to get the sub array sum. Okay, that is sufficient. No. Why no? Aryan, what if now you are saying that you will keep track of the prefix sums, right? Now if I keep track of the prefix sums and I'm saying I will just use the DP itself. Now if I am at this particular state of my DP, right, I know that the sum so far is, let's say, 3. I want something. Let's imagine right now, although in question we'll maintain a prefix sum. Prefix sum is from here up till that end. But right now I'm saying, let's imagine the only portion, this portion. Let's imagine the only portion is this portion, not from the very beginning. Let's imagine this is the only portion. Now for this portion, I would want something which is more than 3, right? So to find something in this range, Now what is this range? Starting from the index I to the very end, which is n-1. Although we will actually see that if we are using prefix sums DP, so we will actually modify that to one index. We'll see that later on, but yeah, we want in this range any of the sum which is more than 3. So you will say, okay, Aryan, at this point of time, my sum is actually it is actually a 2. The sum up till here is actually 2. Up till here it's actually a 4. So I will have to find the lowest possible, again, the lowest possible point where the sum is more than this. Again, I'm saying in the code itself, we will see it's a prefix sum. But right now I took the sum from the sub array starting. So I will be pointing to this value. How I can do it? Aryan, I wanted to search for, I know that okay, it's a prefix sum. Prefix sum of positive elements. Prefix sum of positive elements is always increasing. I know one thing for sure, that this prefix sums array is always increasing. I want to search for something which is more than 3. So I can, again, the number will change, I'll tell you. But considering here, I'll just say, okay, I want something more than 3. I will for sure have to find I will have to for sure search for a value which is more than equal to 3 in my array itself. And that I can just do and search using a binary search. So that's the entire crux of the entire intuition, that you got to know that it's a kind of similar to a longest increasing pattern. In that longest increasing pattern, you will have to maintain the sum of a portion. For that, you can use a prefix sum. But even if you use that prefix sum, you will have to find, okay, if that current value of my DP, because you know that, okay, it's a longest increasing pattern, so we for sure use a DP in that. For DP, if we're using, we will actually maintain the DP state, which is the sum and the length. Okay, it's a sum, but also we maintain the length in a DP. We'll see that part later on. But yeah, we got to know, okay, if you maintain a sum, we actually need to find the next index I should go to, next index I should land on to. That after this index, I can land onto this new index. I can only land onto this new index when I know that the sum is actually more than equal to 3. So I'll just land onto index, this index having a sum of 4. So that's how you can actually simply solve it. So that's the entire crux and intuition. Now let's see, by simply doing a dry run on this example, that how we will solve it. 4, 3, 2, 6. Cool. Firstly, 4 again. I'll just that can be a bit long dry run, as I'll dry run every step for you guys. So that, although if you want to, that was the entire crux. If you want to try, just try it. You know it's a DP, you know it's a binary search, you know how the DP would look like, you know how the binary search would look like, you know what to search for a binary search. It's just that you will have to modify the prefix sums, and that's what we're gonna see in this particular dry run. Now, one part, the indexing are always is 0 based, but you know that our prefix sums are actually, it can also be 0 based, but for simplicity we usually take a 1 based. So prefix sums will actually look like 0, 4, 7, 9 and 15, right? Prefix sums as usual. You will see 0 plus 4 is actually 4, 4 plus 3 actually 7, 7 plus 2 9, 9 plus 5 15. So that's how prefix sum would look like. Okay, that's great. Now for sure we also have to use a DP, right? As we saw a DP state for us in the beginning, we will use a DP, but you saw that okay, here we took the sum of that particular sub array because we want to find and do a bind search on that sum itself. So we will need to maintain a sum. So in my DP, one thing I know for sure, I will need to maintain a sum. That's one thing for sure. But what is the answer? Answer is the length. So in my DP, I should have the length for sure. So I need to maintain in my DP both the states, length also and sum also. How that is helpful, we'll see, but that is required. We can actually see how sum because it is needed for the bind search, and how length because our entire question is based on length itself. So we actually use the DP state of length and sum. I was looking at the likes. Can we please smash that like maybe to 60 likes? This thing was super great. Now we know that okay, we need to maintain a DP state for sure in the very beginning. It's not useful at all. We'll simply say I have a length of 0 with the sum as 0. Here for the other states, I'll say length as 0, sum as infinity, because I want the minimum sum. I want the minimum sum. Remember, right? I want it to be increasing. Now it can actually result in the more length, and why I need this to be increasing on the basis of this value sum. So if I want to be increasing, let's say here the sum is 4. So I'll try to make sure, okay, this is as minimum as possible to have it, to have the length of these jumps as more as I can, so that as more as I can, like for example here, if I have let's say a 5, so still I'll try to jump on to 4 and not 5. Why not 5? Because if I would have a 5, then I would not be able to jump on let's say another element which is okay, let's say if it would have been a 7, so I would not jump from 3 to 7, I'll jump from 3 to 4, because if I would have another array let's say of 6 here, the value 6, which is actually not correct because it's a prefix sum, so it is increasing. But yeah, if I'll try to jump onto the least possible value to have the maximum possible length. Cool. So what I will do is, I know that okay, for right now the sum, minimum sum is actually infinity, because I have not gone to these states. 0 infinity, 0 infinity. Now when that part is done, this entire part is done, we have initialized it. This entire part is done. Now comes the entire main crux, which is this part, and this is what I'm gonna dry run for you guys for the entire problem right here. But make sure that this is the entire part. Just simply copy it up and we'll actually simply use it. Aryan, then what? Okay, let's imagine that we have built the entire DP, and I have for you guys, let's show you. So let's say if I have built the entire DP and it looks like 0 0 1 4 1 7 2 5 and 3 6. It's a final state. Now when I have got the entire final state with me, I can simply go on this entire DP and see what is the maximum length, and that will be my answer. So in the end, I can go into the entire DP where I have both the pairs like length and sum, but I want the maximum length itself. I am not concerned with the sum, so I'll just go and find the length, and that will be the answer. Maximum length I can actually achieve, right? So that is what I wanted. Maximum length what I can achieve. Maximum what I can achieve. Now let's go on to the main part, that what we wanted to solve. So as seen, we'll use this example. Now let's see. Again, make sure that I will use the part which is actually beneficial for you. Again, you just started off with this value 0, 0. You will start off with the, as you see, you will start off with the index 1. Okay, so I am right now at index I equal to 1. Why I equal to 1? Because you will see my actual prefix and DP starts from this value itself. So ultimately I'm concerned about this prefix I'm iterating on this prefix itself. It's my it's my new array itself right now. Why Aryan it's a new array? Because you saw that in the beginning itself I told you that how I am moving in my DP, how actually it will move on the prefix array. Cool. Let's go back. So I just simply firstly have to say one thing. If I am at this value, what is the maximum length I can achieve? So for that, I will go and have to look for the previous sum what I have got. Considering that previous sum I have got is this, it will say me it is the previous length, maximum length which you have got. It is the previous sum of that particular sub array which you have bifurcated. As you can see that the sub array which I have bifurcated is actually nothing. So the sum is actually 0. Length is actually nothing, 0. Now I want something. So it's of no point to try run on this point. So what you can see that ultimately you will, in the beginning, you can only have one element. So you can just simply update this value with a 1 and this with a 4. Again, although I could have dry run for you for this point, but I will not. I'll tell you why. Now, let's move on to the next point actually. And from here itself, it will be much more beneficial for you to understand what will happen next. Now, in this, you saw that it has become a 1, 4. Again, remember the fact that this one represents, so far I've got a length of 1. This represents that the sum of that last sub array is actually 4, which actually represents this part itself. Now, my I equal to 1 was completed. Now I am at I equal to 2. When I am at I equal to 2, what I want, again, what I want, I'm at I equal to 2, I want something whose firstly, I know, okay, it's my previous length, but I'm not concerned about the length. I'm concerned about this sum, and I want something more than this sum. I want something more than this sum. So what shall I search? Currently I am at this point, so please ignore the right part. Right, I am at this point. So I want something more than this sum value. So, and for sure I have my prefix which is actually increasing. So I need to binary search in this prefix. What you will binary search for? Just tell me that. Now, with this can be confusing. Aryan, what shall I binary search for? Shall I binary search for 4? No, you cannot, because you want something more than 4. So what do you want to binary search for? Let's see that if we would have an array, I'll take the same example. If my prefix sum would have been 9, right? At this point, this particular sub array has a value 5. This would have been a 4, which I have not written, and it's the same example. 4, you will see 5. The prefix sum array is 9. Now I am saying at this point of time I want something, and again you will see that the next portion will add, right? The same next portion will add here. Now this will make sure I'm saying I want something more than 5 added, because ultimately I want some new sub array which has a value of more than 5. Simple. Agree on that part? So I'll say I want something who has a value more than 5. So I want 5 plus x. I want this new length in my prefix, because this is the DP was storing. This is the prefix was storing. This is prefix. This is your DP. DP's dot 2. Basically, DP's second value, it is being storing as 5. You want something in your prefix that is added in your prefix that is more than 5, which is greater than equal to 5. So in your entire prefix, you want something which is greater than equal to 9 plus 5. What is this 9? This 9 is prefix sum. What is this 5? This 5 is DP of I. Or basically you can say I minus 1, because you are checking for the last value. I minus 1 dot second. So that is what I wanted. I want this prefix sum. I want to bind search for this prefix sum value as a new value. So what I will do is, I know that okay, my DP of I dot second is actually 4. Okay, 4. But what is the prefix sum value up till that point? It's actually 4 itself. 4 itself. So I want to binary search for a value 8. I want to binary search for a value 8 in my prefix sums array. So what I will do is I'll just do a binary search for, again, it was dp of I minus 1 dot second plus your prefix sum value of what? I minus 1. You will see the same thing. It is prefix of I minus 1, prefix of I minus 1 plus this previous sum, which is actually dp of I minus 1 dot second, dp of I minus 1 dot second. This is what you wanted, what you needed, and you need to binary search on this part. Here you saw it was 8. So your needed value is actually 8. You need to binary search on 8. Now Aryan, 8 you erased. Okay, no worries, we'll simply write this down again. So what element we had? After this we had a 6, right? Cool. We had a 6. So I'll do addition. Okay. I'll have a 9 and then I can have a 0 to infinity. So you will see that, okay, I needed a 6. So I needed an 8. I'll simply do a binary search. Again, there was one more element here, but it's not required, so I didn't write it. I'll do a binary search. I land on to, again, I want the smallest possible value, which is more than equal to 8. I'll land onto the index. Here it is represented by where. So this where says I am at index 3. Again, if you remembered, I was at index 2. I just checked what is the next possible value I needed, and I needed the value 8. How? You saw that if the last sub array sum was 5, you want something more than 5 added in your prefix sums. So you got a value which is more than prefix sums plus the previous value added. Now you just did a binary search. You landed onto the index where you wanted to find this value. Great. Now what will happen is, you know that you will land onto here. One thing is for sure. You know that, okay, this is a possible value, which means you can land onto this index. You have a value which is more than 8. So this binary search will actually find out this index itself. So it has find out, okay, your where is actually a 3. So this binary search part is done, right? Now, when your where is not equal to -1, which means for sure you have got a correct where value, or basically you have got a where value at least, which means it is possible to actually have a where value which is more than equal to 8. That's true. Now, the part is to update this particular value right here. Now, it's very obvious that I was at this value. Let's change this color to green and change this to orange. So I was at this value, right? I jumped on to this. For sure, I am jumping on. So for sure the index, which means the length will increase. Length will become a 1 plus 1. So length will become a 2. Now, what will be the sub array sum length? Simply, you are at this where clause. You are at this where. You know that you jumped from I minus 1. Simply, prefix of where minus prefix of I minus 1. Simply, you will get this sub array sum. So I'll just do the same thing. That prefix of where minus prefix of I minus 1 will give me the sub array sum in this range, which is this entire range. So you will get a 9 minus 4. You will get a 5, which is this particular sum. So you got the sum also. Now this is the expected value which I should be placing here. But I'll just have a pause and I'll ask him, bro, shall I place this value here or not? Now, why I'm asking this value, shall I place it? Why not blindly place? Because I can see it's obvious. It's a 0 length. For sure, you should place it. I'll say, hold on. Yeah, that's true. It's a 0 length. You should place it. But I'll say, even if it would have been a 1 length here, still you would have placed it. Why, Aryan? Because for sure, length is increasing. So I'll just say, existing length. If it's actually less than equal to your this length plus 1, so just the same, this plus 1 is your new value. This plus 1 is your new value. P dot first. So this is a new value. Now I'm saying if the new value which I have got is actually more than the existing value, existing value is 0, and I'm saying even if it is 1, still it's always better to increase the length. So I'll just simply erase this and write a 2,5 here. Aryan, what if this length would have been a 2? What if this length would have been a 2 and something? Then I will say, okay, if the length would have been a 2, then I'll try to minimize this value, which is the sum. Because you remember, if I will minimize the sum, I will be able to achieve the more length. If I minimize the sum, I'll be able to achieve more length. So I'll minimize the sum. So what I will do is, at this point of time, where I've gone, yeah, if this would have been same, I would have minimized this value. So here comes this part. If this value would have been same, right, this value would have been same, so I would have tried to minimize that value, minimize whatsoever value existingly was there of dp of where dot second, minimize this with this sum value whatsoever you are getting right now. It is how the minimization would work like. So you will see that, okay, if the value was same, of this and this, expected p is expected, this p, you will see it's the same value, these are same. So p, which is 2, if this is same, for sure you will try to minimize the second value. But you will see in this case it was actually 0, infinity, so I'll just simply write 2,5. Great, Aryan, great. But is it complete? Is it done? I'll say no. Why no? Because you can see one thing for sure. You were at I index. You checked the previous index and you updated the some other index. What happened to I? Nothing, right? That's how what you will see. Now we will try to see what will happen to I. Now again, there is nothing we can do for I. What we can do for I is we can just simply go and check. Bro, just go and check the last element. For sure, I know that last element has a length of 1. I'm saying I have a length of 0. For sure, I'll just copy him over. I'll just say, okay, bro, come copy over. What I will do is, I'll simply copy him over and say, okay, no worries. The length is 1. The sum. Oh, length is 1, but the sum, if you're copying it over, length you can copy, but the sum would increase, right? Because you are adding a new element. So the sum will be 4 plus, what is the addition? Addition will be nothing but the difference from this to this prefix sums, which means you are adding a value 3 and saying one length. So you are now, now this means you are saying I have one length, but the sum is 7. That is one way you are actually saying this part. So you will see that this will become a 1,7. Now Aryan, you did a 1,7. I mean, like, why? Like, because it was a 0, length was 0. For sure, I should copy over the previous value because it is more. So here it is the logic. If the current value it was 0, previous value length was 1, so I should simply copy over. So I just simply copied over the first value as it is, copied over the last value as it is, but then I also have to add the number, or I can say the prefix sum. Although you can also write the same stuff, which is this prefix of I minus 1, you can simply write it as nums of I minus 1 also. That's also correct, right? Again, the same condition as we discussed for P, which means as we discussed that what if it is same here. What if it is same? If it is same, then simply minimize. How? Existing value of dp of I dot second. Minimize this with the nums of I. It is nums of I minus 1 as we saw here. It's exact same condition. This exact same condition here. Right here. Simply nums of I minus 1 plus the previous value. Simply if the length is same, minimize the sum. If the length is itself less, get the more length. So you will see that we are giving the preference to length first because we want the more number of length, and when the length is same, we are giving the preference to sum. We want the least sum possible. So you will see that I will get the answer as 1,7. Now simply you will see that again in the next step, in the next iteration, what we have got so far is we have simply modified this and got a 1,4, right? We have modified this and got a 1,7 and modified this and got a 2,5. That is what the state we have. Now we will actually be at this point. Let's simply copy this for the next iteration. Firstly copy this. Now we will actually be landing onto this. We have done I equal to 2, right? We have done this 2. Now we will actually be landing onto this value. So we'll land on to I equal to 3. Now, for sure, I equal to 4 will be still remaining. Meanwhile, the folks are watching. I know it's a hard question, but the folks are watching. Can we please smash that like baby to 60 likes? Just one more. That would be super great. Now, when I am at I equal to 3, you will see one fact that for sure I will try to say. Firstly, I'll just go on to the next, like last element. I'll say, okay, its length is this, but I'm not concerned about the length. I'm concerned about the next sum I wanted. Okay, it is the sub-array sum, which is there. Now, Aryan, what is the next expected value? As we discussed before, we know the prefix sum length is actually 7. This value is also 7. I want something more than 7 to be added. So I just say I want something more than 7 plus 7. Here this 7 is prefix sum and this 7 is your DP, which is this sub-array sum. So I'll just say I want something more than equal to 14. Can you give me? Bro will say, yeah bro, for sure I can give you. What is that value? Bro, I'll give you that and you will land on to index this. So my where will land on to index 4. You will see now my where will land on to index 4. Right, cool. Now for sure you have got a proper where. Simply update that. What is the expected value? If I am at this point, I can jump to what? I can jump to this point. Simple. If I can jump to this point, then length will increase. Right, length will increase. Now Aryan, how the length will increase? How the length will increase? Again, if you just remember, it was a 14 I wanted. 7 plus 7, 14. So I just land on to 15. I know that it is a 0,8. For sure, the length will increase. How the length will increase is a fact. Now, I'll say simple thing that I know my value is 7. For sure, I can have a length of 2. Bro, are you saying that you will have this and then you can have this? Yeah, bro, I'm saying the same thing. I can have this and then I can have this. Sorry, I can have this as the value. But bro, one thing, can you tell me? Did you use this? Bro, no worries at all. I'll use this. I'll for sure use this. Just hold on. How, bro? Okay, I'll hold on, bro. So what I'm doing is I'm just trying to check if I can just reduce this up. So I went on to the last value. I just checked the last value and I'll say, yeah, bro, with this value 7, I know that I can land onto a number. But what is that number? That's a question for me. But I know that I can land onto this value. The sum, if I land onto it, will be actually nothing but 17 minus 7. Sorry, 15 minus 7, nothing but 8. So I know that it is expected value, which I should be actually putting here, right? Putting here itself, because I can jump from here to here. Again, this is the length, new length, because you know the earlier length was 1, and this is a new sum value, because you know that it's the length of 7, it's a length of 8. Again, it's increasing sum, so it's a good for me. Now the same condition will lie. Okay, we have got the correct P. Same condition will lie as we discussed. If this value, existing value, you will see existing value is a 0, which is less than 2. Even if it would have been a 1, it's still less than 2. So for sure, I can just simply update this. I can just simply update this entire stuff and say the value is 2,8. Aryan, what if the value would have been same? If the value would have been same, which means the length would have been 2, then I would have minimized the sub-array sum value. But here the length is less, so I'll simply update that. Okay, cool. That is done. When your where part is done, then you actually go and check for the current value. Right? You just simply go and check, bro. just let me know if this length is actually less, which means I just go and check, okay bro, I am less, no bro, I'm not less, bro, I'm equal, no bro, I'm equal, bro, I'm more, then just chill, let's go on. I am more, I'm already more, just simply go on, I'm already more, I'm good. Okay, cool. Then in the last iteration, let's copy this entire thing up and let's see the last iteration. In the last iteration, what will happen? Okay, your I will actually be at the last point, right? Your I will actually be at the last point. I go to 4. Again, same thing. You will just go and check, okay, it is the previous length, it is the previous sum, which is the sub-array sum. What you want now? Again, you want something, as you saw, this is the prefix sum, 9. This is the last sub-array sum. You want something more than equal to 5 added in your prefix sum, so as to have the new prefix sum. So you want something more than equal to 14. 9 by 5, 14. So I'll say, bro, yeah, that you are correct. I want something more than 14. My needed is actually 14. So I want something more than 14. That's great, bro. Then what will happen is you will land onto this index. Your where is actually this index itself. Great, bro. That's great. So what will happen is now my where is this pointing to this. So again, I have got my where with this binary search. Now my where is actually possible value. So what I will do is I'll simply go and check, bro, what is the expected value? If I jump from here to this where value, what's the expected p value? So it will say, bro, length will increase, so new length will be 3, bro, and also your sub-array sum will actually be from here to here. So I'll do a sub-array sum of 50 minus 9, 6. So now I have got this p value which is expected. Now I'll just go and say, what should I do with this existing value of my dp? My dp existing value is 2,8. For sure the length is less, the length is less, so I should blindly update the new value. What if the length would have been equal? Let's say if the length would have been equal, then I would have minimized my sum. Simple as that. But here the length is actually, the length is actually less, so I'll blindly update it with this value, new value, which is the new length, the length and the last prefix and the last sub-array sum. Cool. Now when this part is done, now you are at this I, you will just go and check with the previous value, bro, what is the length you have, what is the length I have? Okay, like you have a length which is less. Oh, no worries, I can just simply go on, and I simply go on. So that's how your entire array will be built. Ultimately, as I showed you in the very beginning also, when you have got the entire array built, you will see the entire array built for us. You have got the entire array built for you. Then what you will do is simply iterate on the entire dp. Well, it was your dp array. Simply iterate it and get the maximum length, because that was your answer. And with this, you can simply solve this in O of n log n. I hope that you guys got it. Cool. And the code, again, we have gone on through the code very long, like very much, because of the 4 dry runs which we had. But still, here we are finding the prefix sums, then we are finding the dp default values, then we go and find the needed value. Again, I showed you the proof of this, why it is actually true. Then I did the binary search for this needed value. Again, I showed you that part also. Then wherever that binary search lands me, I will go and find the expected p value, which is the new value of dp, which is the expected value, which I should or should not use to replace my existing dp value. If the length is less, for sure update the existing dp value. If the length is same, then minimize the sub-array sum. This is for the where, which means what my binary search pointed to me. But what about the current index I? For that also, simply just go and look for the last value, previous value. If the length is less, simply copy off the previous value of dp of I minus 1, but with a modification that you have to increase the sub-array sum also. So that I have increased the sub-array sum. But what if the length is same, the length is same, then simply copy the previous value, which is the previous value, but then length will actually, this part will be added for sure because you are adding something, and then the length will actually be remaining same. With this fact, you can actually simply get this solved, and you will have your answer in your DP in the length part, and you can simply return the maximum length as an answer in O of n log n. So that was it. We'll go on to the comments very quickly. I hope that you guys got it, liked it. If yes, then can we please smash that like baby to 65 likes? That would be super great. I'm very thirsty. I'll just have some water, but yeah, that would be super helpful if you can please smash that like baby to 65 likes. That would be super great. Any doubts whatsoever, just write down below. We'll go on to the comments quickly. The way you explain this makes quite easy to understand. Thank you so much, Sathak. This question is quite hard. Yeah, true, that's true. Infinity Gaming. सर आप पटेल हॉस्टल में किस रूम में रहते थे? एमएनआईटी पे एमएनआईटी पे में भी पटेल हॉस्टल में रहता हूँ, एमएनआईटी सीएसई में हूँ. ओम गुप्ता, आई वाज इन G98. लवली रूम. क्या व्यू था यार उस रूम के आगे, मजा आता था. भैया आई वाज नॉट एबल टू डू 2 and 4th question. See, Infinity Gaming, in this contest I'll say that 2 was a bit tricky, so we can take that question light. 4th was for sure tough, so that is obvious that we won't be able to do it, but yeah, a bit intuition that maybe DP can be applied, or maybe by such, maybe a very overkill to think of, but yeah, at least thinking very vaguely, at least thinking or having an idea that maybe DP can be applied, so that would have been great. But yeah, still 4th question is very tough, but thinking of the logic was a bit easy part. I'm not saying easy, was a bit medium part, but then implementing was a very hard part. Cool. Om Gupta आंसर बता दिया है. It will be very helpful for me, Aryan bro. Yep, Pratyush, thank you, समझ गया. Thank you so much, Krishna. To segment 3 playlist needed. Bro, for sure we'll try to bring it up. It's just that like I have tried this Insta page specifically for you guys, just so that you understand things much better, because you like memes, I like memes, you like trends, I like trends. So I tried to explain this in the form of a trend and logic. So you will see that in this we are just having a we are having a concept of linked list and stuff. So yeah, that is how entirely things I'm planning. So I don't get much time, but yeah, I'm trying my level best to actually manage things up. If you want to learn for the fun stuff, you can just go and follow this, but yeah, that's how things are. Cool. It will be helpful for me, bhai. Pratish, what is helpful? Haran, please give the code. Cool. So if you have any doubts, then that's great. Thank you so much for watching. See you next time. Take care. If you have, like, I'll wait for a minute or so. It's 12:38. I'll wait until 12:40. Let's see if you have some comments, and then we are in the stream. Cool. Okay, we have Infinity Gaming. Bhaiya, I think your coding level is on 6 or 7 star in Code Chef. I followed you. Like I left Code Chef way early, like way early, because later I realized that in college you do competitive programming because you are doing it. Because see, if you have played Clash of Clans, then you must have remembered. Arey bhai, listen, please wait. Pratish, you write your comment just once, so that I can just figure out what your comment is. Then we can actually discuss on that comment. But yeah, if you had known that in college we used to play Clash of Clans, right? Now, playing Clash of Clans, if you don't know Clash of Clans, for the folks who know Clash of Clans, it's a group game. Your team comes in, your team actually plays against another clans. So in Clash of Clans, why it was so much, interesting to play or so much addictive to play was because you and your friends were actually competing in Clash of Clans to actually maximize your houses, maximize your levels, and increasing your levels. So that made that game competitive. It was not competitive when I was playing with someone else I don't even know. That is what is the same concept of competitive programming. When you are in college, you have an environment, you have someone playing, you have someone solving problems, so you have a competition going on between yourself, who will have more problems solved, who will have more knowledge, who will have more stars or something like that. So that is what helps you make sure that you achieve better ranks, and that's how a craze of Codeforce and CodeChef comes in college. But as soon as you get in the industries, which means in the corporate world, you will see that everyone is going to office. No one is doing CodeChef, so you don't, like, none of my friends from college are doing CodeChef or Codeforces. The ones who were candidate masters, who were masters, experts, no one is doing the CodeChef. Why? Because firstly, we are busy with our college work, and usually in the corporate life, it's just weekends, enjoying weekends. I don't know what's the fact with that, but yeah, people just usually go and enjoy weekends in the name of enjoying weekends. Then comes the part, what if I want to switch the company? Then folks realize that the Codeforces was never required. Leetcode was more than enough. Then how the trend shifts that after college, no one, roughly, like I will say, like legit 1% of the folks out of 100, because everyone in college used to do Codeforce because we had time a lot, and we just love solving and having a group. Because in my college, my roommate used to do, my roommate, like we have a room, let's say G98, so G99, G90, like G100, G101, every room, like we used to have entirely, like we used to give every contest and stuff, so that was a group competition which used to go on, and we actually used to enjoy that part. That was a fun way of saying that we are playing against each other, and that's what is competitive programming. So yeah, I'll say, like, if you are, like, for sure, like you guys are in college, and sooner, you guys will realize that it's just a fun way. It's a sport. Codeforce is a sport. Leetcode is a necessity. It's a requirement. Cool. Thanks a lot, Bhaiya. Thank you so much, Supreet. Your explanation for vocation was very easy, bro. Thank you so much, Krishna. Arey bhai, Pratyush, yaar, please write your comment once. I was not able to understand your comment. Bro, what is a tough process for memorization and recursion? What is the thought process? See, memorization is just writing in your return. Firstly, before entering recursion, just write the if condition, that if that is not equal to -1, or basically not able to find that value, if that value is already present, just return that value. Before returning the value itself in the end, just simply have the assign. That's a simple memorization in recursion. That's all. So yeah, भैया, बट समटाइम्स बहुत फ्रस्ट्रेशन हो जाती है जब कोई टॉपिक कर रहा हो और उसका क्वेश्चन ना हो. That is, yeah, Sukhpreet, that is super true. But that is how things are, and that what makes this journey interesting, that we will solve it, we won't be able to solve it. Acha, I'll just say, like, have you watched that trend Moe Moe? Like, while like at this point also, I was solving the question contest, and I was like stuck on that question number, like I got a wrong answer on the question number 3. I was debugging that, why is that wrong? I was like wrong in, because the logic was actually wrong. So I was just debugging that part, and then I was like ready. Like I was just in a stress so much. So yeah, like just imagine me knowing the same problem and me having solved that same problem previously. Still, when I was stuck at that problem, I got the wrong answer. I was like, I got the wrong answer? I have done the same problem so many times. How come I have got the wrong answer on that? So still, it happens with me. So it still is possible that gives you frustration for sure. How come this can be wrong? And what if in worst case, the entire contest would have gone and I would have started thinking something else for this question. it could go wrong. It could go wrong, and it have gone wrong. In one contest, I could only solve 2 problems, and that is possible. So some things sometimes will teach you something. So yeah, we just have to trust the process for us. Aryan bhai, profile review karo bhai, please. Yeah, we can do that for tomorrow's contest. This is actually a bit late, so we'll actually end the stream. But yeah, we'll actually solve it in tomorrow's contest. You can just write your profile names. I can just review that up, but it's a bit late. I have got the notification from the neighbors that I'm shouting. I have to speak slow. That always happens with me. But cool. Well, it's true, because industry work is different than the code chef, and you guys don't have much time to give in the code chef. Yeah, that's true. That's true. Cool. That was the questions. It from you guys. Thank you so much for watching. Meanwhile, before going, can we please smash that like baby to 70 likes? Just 2 more. That would be super great. Cool. Pratyush, we can actually review that tomorrow because it's pretty late, because we want to have tomorrow's live stream also. So yeah, 11 a.m. if you don't know, every day, weekly. Thoda sa time, please, bhai. Acha, theek hai, just mention your, at least mention your Leetcode profile name so I can review that. But yeah, you can still come tomorrow also. Cool. Thank you. Bye bhaiya. Bye Infinity Gaming. Thank you so much for watching. See you. Bye bye. Thank you, Pratyush. Even if I'm not able to solve it, still just mention it. We will review in the tomorrow's contest for sure. No worries. Don't bye, Krishna. No worries to actually like. It's chill. Like, we come every day, every week, every bi-weekly, every weekly we come for sure. Cool. Bye. Thank you so much. Goodbye. Good night. See you tomorrow. Do give every day. Do solve every day's questions, and who solve every contest. Bye Sarthak. Bye Krishna. Bye Pratyush. Bye. How to end the stream? I forgot. Cool. Oh, I am still not live. Okay, what is this end broadcast thing? How to end? Is it live, right? I'll end.